I'm Keitaro Tanaka from Waseda University, Japan. I'd like to make a brief presentation entitled Multi-Instrument Music Transcription based on deep spherical crossing of spectrograms and pitchgrams. Our research goal, multi-instrument music transcription, is to transcribe arbitrary musical instruments in the music audio signal. This transcription deals with music signals played by any harmonic instruments. First, we specify the number of instruments in advance. Then, we estimate piano rolls of multiple instrument parts. For example, given a piece of music played by piano and clarinet, you will get the piano rolls of these two instruments. Most conventional methods based on supervised learning of deep neural networks can deal with only predefined instruments included in the training data. So, it is impossible to transcribe undefined instruments that are not included in the training data. This is a serious problem because various kinds of instruments are used in modern music. One remedy to this problem is timbral-based clustering, which is expected to deal with any kinds of musical instruments. Here, we assume the number of instruments is specified at runtime. For example, a piece consisting of these three instruments is transcribed like this, and another piece is transcribed like this. In addition, a piece consisting of two instruments should be transcribed like this. For this purpose, we focus on deep clustering, which was originally proposed for separating a speech mixture based on the characteristics of voices. Once the number of speakers is specified at runtime, we can separate an arbitrary number of unsigned speakers from a given mixture. In speech separation based on deep clustering, each time frequency bin is embedded into a feature space and K-means clustering is conducted for estimating masks used for separation. Here, the TF bins of the same speakers are embedded as close as possible, and those of different speakers are embedded as far as possible. Our key idea is to use deep clustering for part separation in the task of multi-instrument music transcription. In speech separation, deep clustering is conducted in the spectrogram domain. In part separation, deep clustering is conducted in the pitchgram domain. Here, we need to obtain a condensed piano roll for deep clustering-based part separation. We use a pitchgram as a proxy of condensed piano roll, where the pitchgram is obtained by using a newer multi-pitch estimator. We have explained deep clustering-based audio separation and part separation contrastingly, but there are complementary relationships between these two tasks. This calls for another key idea, joint part separation, where we make effective use of such complementary relationships between the part separation tasks in two domains. As can be seen in this table, our method can transcribe unseen instruments as well as known instruments used for training. This is an example obtained by the proposed method. The proposed method can successfully achieve multi-instrument music transcription. In this study, we proposed a multi-instrument music transcription method based on deep clustering. The pitchgram and the spectrogram of a music signal are jointly embedded into feature species, and K-means clustering with a specified number of instruments is conducted for joint part separation. We found that unseen musical instruments can be dealt with, as well as known instruments used for training. Thank you for listening.